Hello, my name is Kelly Ann Marie Carlson, team captain of First Robotics Competition Team 2403, Plasma Robotics. In the fall of 2010, I enrolled in the engineering program, Project Lead the Way, at Red Mountain High School in Mesa, Arizona. My freshman year, I was the only female student and one of only 2 freshman students taking the class. My engineering teacher encouraged me to join the robotics team, and I've been enthralled ever since. In May, I will graduate with the honor of being the first female to complete the 4-year engineering program for the entire Mesa Public School District, and the first girl to complete all 4 years on Plasma Robotics. Plasma Robotics was the first team in Mesa. Plasma has helped quintuple the number of FLL teams in Mesa over the past 3 years, start FTC in the Mesa Public School District, and has established a new FRC team every year for the past 2 years. First semester and second semester, the team operates using different leadership structures. During the build season, students are in charge to ensure that the robot is designed and built by students with input and support from team mentors. Each leadership position, from project managers to section leaders, are led by a senior but have an underclassman shadowing them to help decrease the learning curve for future years. Each subgroup is broken into smaller groups, each of which have separate leaders. The structure allows for a large number of students to hold leadership roles and learn the responsibilities associated with working in an organization. When the 2014 game was revealed, leadership established 4 specific groups for the build season: shoot, pickup, catch, and programming, and then had team members divide themselves into the groups that interested them. The 6-week build season was broken into 3 2-week sections. After the first 2 weeks, each group gave a presentation to the team on their ideas of how to tackle their problem. This was repeated at the end of week 3 after further testing had occurred. The presentations were something new that we established, but it had great results. Each subsection was able to work independently of the other groups to design the best mechanism, and then they presented their top ideas to the team and explained how each of these ideas worked. After the presentations, section leaders and project management sat down to decide which ideas would work well with each other and fit within a 28 by 28 inch frame. This meeting ran off of principles of teamwork and compromise. Each student had their own unique ideas and research to justify their decisions, but the team had to work as one unit to establish what would be most successful. Plasma Robotics' 2014 robot, Richard Simmons, is very unique looking. The robot is less than 2 feet tall and sits on a 28 inch frame. One of the most innovative features to our robot is the pickup mechanism. The pickup group looked to Plasma's 2012 robot for inspiration. In the 2012 year, the robot used a conveyor belt, tubing, and plastic cylinder to suck up a foam basketball and load it into the hopper. So, for a closer look, we have this diagram. As the robot approached the ball, it would begin spinning a shaft, which was keyed into a plastic cylinder. The cylinder was actually a series of wide plastic spacers with plaction attached to the outside and grooved cylinder pieces which acted as a guide for the conveyor belt. It could quickly pick up the basketball from the floor. When it came time to build the pickup for the 2014 robot, the team actually took apart the 2012 robot and tested the pickup mechanism on the 2-foot diameter exercise ball. It worked well, but was obviously too large for the bot. Additionally, the conveyor belts proved to be an issue during the 2012 season since they would easily stretch and were very hard to reattach and fix. The final design came down to this. Aluminum braces from the 2012 robot were cut down, re-drilled, and were reused as braces for the 2014 robot. The plastic rollers acted as inspiration for one continuous plastic cylinder, which was Swiss cheesed for weight and had 2 attached to the outside. The conveyor belt was replaced with small standard belt, which had a longer lifetime and less of a chance of stretching during the competition. The fact that team members were able to gain inspiration from a robot that was just sitting in the build room was incredible, and it allowed veteran members to provide input from their previous experiences with the design to make an even better mechanism for this year. A lot of communication and teamwork was used in the final mounting point for the pickup mechanism. The shooter ended up having to be mounted higher than originally anticipated because of the surgical tubing used to provide elastic energy was rubbing against the stem motors which powered the drivetrain. This meant that the pickup needed to be moved higher. With the final design, the pickup and shooter worked together to successfully manipulate the game piece. With a strong plan of attack and team members who were willing to work together, Plasma Robotics had a successful build season. I am extremely proud to be a member of FRC Team 2403 and cannot wait to participate at the Arizona and Las Vegas Regionals and qualify for the World Championships this year.